Hello everybody, my name is Mandeep Singh Malhotra. I am M.Tech second year student at Nanak Engineering College, Ludhiana. This video is for seismic resistant building design assignment and this is my second assignment to be submitted at Skyfi Labs. The section properties, plan and elevation and dead and live loads of the building is same as that of first assignment. In this video, I will show how to define seismic loads and then run the analysis and design. After this, seismic analysis will be done with response spectrum method and then with time history analysis also. Now let's start the video. After the building is modeled and dead and live loads are assigned, we have to define the seismic loads. For defining seismic loads, go to define load patterns. Here I have already defined the seismic loads. We are considering that the seismic waves will be acting at both x and y direction. Therefore, x and y directions are marked. We are not considering the eccentricity. The response reduction for ordinary moment resisting frame is 3 according to Indian standard. As Bangalore falls in zone 2nd and for zone 2, the zone factor is 0.1. We are assuming medium soil at that location. Therefore, soil type is 2 and time period is program calculated. Okay. Now we have to check for load combinations. Here are the load combinations: dead load, live load and other seismic load combinations. Now we can run the analysis of this building. When the analysis is over, this building will show its deformed shape. Wherever we point the cursor, the displacement at that point will be shown. Now the analysis is over and we can run the design. For starting the design, ensure that IS456 is selected as preference and start the design. As we have selected the auto select option for beam and column sections, we will allow it to reiterate. Again allow it to reiterate. Now the designing is over and this 3D building model is showing the longitudinal reinforcing values for beam and column sections. Now we have to verify whether all members have passed the design check or not. So all concrete frames passed the design check. This completes our analysis and design. And if we have to show the report, here is the project report and a summary report. This report will be shown here, which will include all the important values like load patterns, load combinations, sections of beams and columns, etc. Now we can move on to the next method, which is seismic analysis by response spectrum method. We have to unlock the model and define the response spectrum function. Before defining the response spectrum function, ensure that the seismic loads are defined. Make sure that X and Y directions are marked. Now we can define the response spectrum function. Select the Indian Standards IS 1893-2002, add new function, name it as response spectrum. Fill these parameters based on your location. And now, okay, now our response spectrum function is defined. Now go to load cases and add new case, name it as response spectrum. Select load case type as response spectrum. Add load type is acceleration, load name U1, function is response spectrum. Scale factor. To calculate scale factor, the formula is Ig divided by 2R, where I is importance factor, G is acceleration due to gravity in mm per meter square, and R is response reduction factor. We get scale factor as again add load applied for y direction also, load name as U2, function as response spectrum, scale factor is same. Okay. Now we can set load cases to run. There is no need of dead and live load cases to run. Therefore, make the action as do not run for dead and live loads. Now run analysis. The analysis based on response spectrum method is over. The building is showing its deformed shape. Now we can design. We can start the design. Ensure IS 456-2000 is selected and start the design. Now the designing is complete and the 3D model of building is showing the longitudinal reinforcing values for beam and column elements. Now we can verify whether all members have passed or not. So all concrete frames passed the design check. In the Model Explorer column, there are project report, summary report, this is the summary report which includes all analysis results and all other information related to the building. This completes the response spectrum analysis, and now we can move on to the next analysis method, that is time history analysis. Before defining the time history function, ensure that seismic loads are defined. Here we consider that seismic waves will be acting only in one direction, therefore unmark y direction. Fill all other parameters as per your location. Now we can define the time history function. Choose function type to add from file. Add new function. Name it as time history. We are importing time history data file of Bhuj earthquake that occurred in the year 2001. Header lines to skip are 9 as per the time history file. Number of points per line 1. Format type is fixed format. Now okay. Now go to define and load cases. We don't need response pattern. Delete this case. Add new case. Name it as time history. Now we can click on OK. The time history load case is defined. Now we can set load cases to run. Make sure the dead and live load actions are do not run. Now we can run the analysis. The analysis is complete and the 3D model of the building is showing its deformed shape. We can now start the design. Now the designing is over. The 3D model of building is showing longitudinal reinforcement values of beam and column elements. We can now verify whether all members have passed or not. All concrete frames passed with the design check. Here our design is also over. We can now check for the project report and summary report. We will not be able to print the project report in the evaluation versions of PTABs. So this is the project report, which includes all the analysis results, load patterns, load cases, etc. for this building. This completes our video. Thanks all.